All right, guys, we are looking at learning targets 6A and 6C. These were graded together. They say I can recognize the relationship between square numbers and square roots, and I can evaluate the value of a perfect square. So those two learning targets coming together for your grade that you got there. So it says here that the square tile below has an area of 324 square inches. What is the perimeter of the square tile? So I'm going to write 324 here because I know that the area is 324. And so I know that in order to find the side length, first, if I'm going to be finding perimeter, I need to be finding that side length. And if it's a square, I know that this side length and this side length are going to be the same because it's a square. And so I'm trying to figure out what times what equals 324. And so if I were to work it forward, if I knew this number, I would say this number squared is going to give me this number. But I know the opposite of squares is square roots. So I'm going to say that if the area is 324, then the side length is the opposite of the square, and it's the square root of 324. Square root of 324. So it's kind of hard for me to think about the number square root of 324 since it's not something we use every day. We need to be putting it into the number system that we are more comfortable with. So the square root of 324 is one of the ones that we should have memorized. We should be up to 20. And if we don't, we need a system that works for us. Like we need to be testing them out and doing things like 15 times 15 and finding out what that answer is. And you would see that that would be 225. And 225 is smaller than this. So you'd be going up and you would say 18 times 18. And when you did that, you would realize you have 324. And so when you do that, you see that the number square root 324 is the number 18. Okay? But what it's not asking for just 18, it says what is the perimeter. And so if I have 18, then I need to take 18 and I need to add it together 4 times to figure out what the perimeter of that tile is. So 18 plus 18 is 8 plus 8 is 16, and that gives me 36. And I'm going to have another 18 plus 18, and that gives me 36. And so then I have to add together my two 36s, and that gives me 72. And so the area is 72. All right? And then the second part says, write the equivalent integers for each square root. An integer is a whole number, positive and negative, okay? So square root 16 is equivalent to 4. And square root 81 is equivalent to 9 because 9 times 9 is 81. And so the square root of 81 is 9, and 4 times 4 is 16, so the square root of 16 is 4. And the square root of 225 is 15 because 15 times 15 is 225. And I would see that by doing 15 times 15, and I'd be coming up with 25 here, that's 75, and then I add a 0, 5, and a 1, and I would carry that, and I'd end up with 225 as the answer. And so I know 15 times 15 is 225, so therefore square root of 225 is 15. Okay? Square root of 289. Well, I know up here that 18 was square root 324, so I know it's got to be somewhere between 15 and 18. And also knowing my the end number here can give me a clue because it should be like the number 7. 7 times 7 is going to be 49, and it ends with a 9. So this has a possibility of being 17. Whereas if I do 6 times 6, that's 36. Ends with 6, this one ends with 9, so it's not going to be 16, and it's not going to be 18, so it must be 17. So I can try that out, and this time I'm going to try that with an area model for multiplication instead of that standard algorithm there. And I'm going to test out 17. So I've got 10 and a 7 to be 17, and 10 and a 7 to be 17. 10 times 10 is 100. 10 times 7 is 70. 10 times 7 is 70. 7 times 7 is 49. And when I add these parts up, I've got 100, 70, 70, and 49. So I've got 9 there, and I've got 7 plus 7 is 14, plus another 4 is 18. Carry that 1, and you end up with 289. So So therefore, 17 squared is 289. So the opposite of that would be square root 289 is 17. Okay? So again, just practicing those squares and getting them memorized and knowing them. So this is part of, it's like memorizing multiplication. You just got to memorize your square roots from 0 to 20. Write the equivalent square root for each integer. So we are doing the opposite of what we did. And so some of us might look at square root 4 and say it's 4, and look here at 16 and be like, it must be 4, square root 4. But it's not, right? Because we need to take 16 and square it. We're trying to find the equivalent square root for each. So we would have to do 16 times 16. And I'm going to use an area model to figure this out. There's 10, there's 6, that makes 16. There's 10, there's 6, that makes 16. 10 times 10 is 100, 10 times 6 is 60, 10 times 6 is 60, and 6 times 6 is 36. And adding these parts together, I've got 100, 160, 220, I'm at 220, and I'm going to add 36 to that, and I've got 256. So the equivalent value for 16 is square root 256. And the equivalent value for 5 is square root 25. And the equivalent value for 7 is square root 49, because 7 times 7 is 49, so 7 is equal to square root 49. And 19 is another one of those hard ones. So again, I'm going to draw out an area model. I'm using multiplication. I'm using a strategy that was taught in probably 4th grade. Somewhere between 3rd and 5th grade. And so using that knowledge that we've been taught at some point, those strategies are extremely useful. And they're not just useful for that year, but the years to come. So I've got 10 plus 9, that's my 19, and I'm going to multiply it by 19 here. 10 times 10 is 100. 10 times 9 is 90. 10 times 9 is 90, and 9 times 9 is 81. I'm going to add up all those parts. So I've got 100 plus 90 gives me 190. I'm going to add another 90. 9 plus 9 is 18. So that's 280. And then I'm going to add 81. And I've got 1, 16, and that's 361. So square root 361 goes there. All right. So I just did all of that. I did it pretty quick. You can go back, you can slow it down and listen through it and reason through it. But something I want to talk about is the work that I showed here. Okay. In math, everything should not be happening in your head. In math, some things happen in our head, but a lot of stuff we need to record down on paper as we're doing multiple steps so that we don't forget what we're doing, okay? You're going to be doing that on your own. Down below, it doesn't say it, but there should say on your own right here. And I put on, own it. Own your own. I meant on your own. You're going to do this on your own in a reflection of what we did up here.